Welcome back to lesson U2A6, and now we're going to take a look at example number 4. This is the second part of the lesson, or the second video. So in this example, we are given a line. An equation of a line is given in parametric form. So we have x equals 2 minus s, y equals negative 1 plus 3s, and z equals 4 minus 2s. We'd like to find the intersection made between this line and a special plane in 3D, that of a YZ plane. Remember that on the YZ plane, the y and the z coordinates will be 0, and that's why the equation of this plane is described by just the x coordinate. So x coordinate is negative 3. So imagine that if you had the equation in the form ax plus by plus cz plus d equals 0, we will see that on the yz plane, since y and z are 0, that will make these terms equal to 0. So we have just the x term and the constant that represents the whole plane. Now, if we want to find the intersection point between this line and this plane, then we'll need to make sure that these coordinates will fit into this plane. So for this, we're going to use the first parametric equation, so x equals 2 minus s, into the equation of the plane. So this is from the line, and from the plane here we have x equals negative 3. So with an x value of negative 3, we'll go back to the parametric equation for x, and we'll say that since x equals negative 3, then we'll have negative 3 equals 2 minus s. So remember that at any point on this plane, the x value will be negative 3, and that's why we want to substitute this x value into the parametric equation. So that means we have negative 3 minus 2 equals negative s, which makes the value of s equal to 5. So therefore, we're going to say that the y-coordinate will be negative 1 plus 3s, or negative 1 plus 3 times 5. That will give 14. The z-coordinate will be 4 minus 2s, or 4 minus 2 times 5, which will make the z-coordinate equal to negative 6. So therefore, we'll say that the point of intersection is at x equals negative 3, y is 14, and z equals negative 6.